In the last video on LoRa Specialization, we had a look at how to configure STM32Cube IDE to write a C++ program, as well as write a simple program using class to turn on and off an LED. From this video onwards, I will be starting to implement a ping-pong example step by step from scratch. I would suggest you to watch the previous video, but I will do recap in this video. Let's look at a system diagram of the ping-pong project and see what we are going to implement first. In this experiment, I'm gonna use LoRa transceiver SX1262 from Semtech that is controlled by a MCU STM32. One MCU will be configured as a master when it is transmitting a ping message, and the other will be act as a slave when it is receiving the ping message. In the second scenario of the project, the master MCU become a slave, meaning a receiver, and the second become master or transmitter and send a ping message. This is an overview of the LoRa transceiver component. There are three main components: bus device or MCU, LoRa transceiver chipset, and RF switch. MCU communicate with the LoRa chipset via SPI protocol. There is NSS pin, which is used as a slave chip select. There is N reset pin, which is used to reset the LoRa chipset. Busy control line is used to indicate the status of the internal state machine, meaning when the busy line is held low, it indicates the radio chip is ready to accept a command from the host controller. SX1262 has three multi-purpose digital input and output, or DIO. These three DIOs pins that can be configured as an interrupt, debug, or control the crystal or RF switch. In my development board, I make a use of DIO2 to control RF switch, and DIO1 as a TX and RX done interrupt. There are other design files that is configured DIO3 to be used as a power regulation for TCXO. There is an antenna switch pin from the MCU which is connected to the RF control line, and with the combination with the DIO2 from SX1262 will control the signal path. For example, if LoRa chipset is working as a transmitter, the RF switch flow the signal path to RFO pins, or it is working as a receiver, it will connect it to RFI pin. Before starting to write the program, let's do the planning and visualize what we are going to write. We would have 4 stacks of the files: main.c++ where we keep all the MCU GPIO and peripheral settings, my app where we keep all the application functions, radio class is a base class to keep all the callback functions and share them between the other class. SX126X class is a drive class and is publicly inherited from the radio class, where it keeps middle layer functions such as initialization, setup payload, and setup synchronized word, and so on. SX126X Hall class is a drive class which is publicly inherited from the radio class, where it keeps lowest layer of the program functions such as write command, read command, and read from the register, and so on. I have created some source and header file to make the program more systematic. We have main source file where include the MCU, GPIO, and peripheral setting. My app.c++ is the application layer of the program. It keeps all the settings of the LoRa based on the application such as frequency, master or slave, and so on. Radio.h is a header file where we keep all the callback functions such as transmit done, receive done, and so on. SX126S is a middle layer where we configure LoRa internal registers to be operated correctly, for example TX parameters or buffer base address or get RSSI. And the last one is SX126S Hall is a lowest layer of the program where we keeps all the basic communication function such as read command, write register or read from the register. Let's get started with the radio class declaration, which is a base class and the two other classes will inherit the public element from that. Generally speaking, there will be three classes in this program: radio class, SX126S, and SX126S Hall class. We have done with the class declaration. Let's compile the code and see whether there is any error. That's great, there is no error. In the next video, I will be writing initial function as well as reset function. I hope you found the video useful and see you in the next video.